We're going to talk about an example that talks about finding the area between the curves. So we have x equal to y to the fourth, y is equal to the square root of 2 minus x, and y equal to 0. So to do this, we're going to first sketch the region. We're going to find points of intersection. We're going to set up an integral, and then we're going to solve. So to sketch the region, okay, we have x equal to y to the fourth, and x equal to y to the fourth is a graph that looks something like this. And then we have y equal to the square root of 2 minus x. Well, we know that the square root of x graph is a graph that looks like this. So if we have y equal to the square root of negative x, then that graph is going to look something like this. And then we're going to shift it 2 units to the right. So when you shift 2 units to the right, you're going to have something that looks like this. And then we have y equal to 0. And y equal to 0 gives us this line. So the area between the curves is this area here. So you need to first make sure that you clearly establish what it is that you are working with. Okay. I also want you to notice that these two graphs or these two curves intersect somewhere. And to figure out where those two graphs intersect, what you can do is you can solve by substitution and say y is equal to the square root of 2 minus y to the fourth. Or we can say that y squared is equal to 2 minus y to the fourth. Y to the fourth plus y squared minus 2 is equal to 0. And let's factor. Y squared plus 2, y squared minus 1 equal to 0. We have y squared plus 2, y plus 1, y minus 1 equal to 0. You can clearly see that these two curves intersect at a positive y value, and that positive y value would be at y equal to 1. Okay? So if we're looking for y equal to 1, well, if y is equal to 1, 1 to the fourth power is 1. So the point of intersection is your point 1, 1. So what we want to do is we want to now set up the integral that will allow us to find the area between these two curves. Okay? You can do two things. You can integrate with respect to x, or you can integrate with respect to y. Integrating with respect to x will require you to set up two different integrals. And integrating with respect to x will give you, let's say, the area of the first region and the area of the second region. So rather than integrating with respect to x, what we're going to do is we're going to integrate with respect to y. And if we integrate with respect to y, then we need to create a reference rectangle that looks like this. Okay? Think about this reference rectangle. This horizontal reference rectangle, because remember, the area is just going to be the sum of all of these little rectangles here. So this reference rectangle, when you create it, it's moving in a y direction. So when it moves in a y direction, then you only have to set up one integral. Okay, so if you want to know how we set it up with respect to x, just let me know and I can talk about it in a video, in a different video, or in class if we are taking the class this semester. Okay, so we are going to integrate with respect to y. Well, integrating with respect to y, let me delete this, requires us to set up the following integral. So we are going to say the area is equal to the integral from C to D, from that lower number. And what is that lower limit of integration? Well, that y value is 0. And remember, the upper one is 1. So we're going to have the area is equal to the integral from 0 to 1 of what is it? Well, when you set up this problem, you can say that that is equal to f of y, because we're integrating with respect to y, minus g of y. Okay, so f of y minus g of y. Or what is your f of y? The f of y is equal to this right here. So what was it? Y is equal to the square root of 2 minus x. But rather than writing it with respect to x, we need to write it with respect to y. So we have y squared is equal to 2 minus x. Or we can say that x is equal to 2 minus y squared. Okay. You can also think about it as the distance from here to here is x. And that particular x is your curve. And what is that curve? That curve will be 2 minus y squared. Okay. So we have 2 minus y squared minus the g of y. And what was g of y? G of y is y to the 4th. dy. You can also think about it in terms of the right curve minus the left curve. Okay? So that part here is your setup. What I suggest you do is you pause this video and try to solve it on your own. Try to finish the integration on your own and see where that takes you. So I'm going to continue doing it. We have the integral from 0 to 1 of 2 minus y to the 2nd minus y to the 4th dy. So we have 2y minus y to the 3rd over 3 minus y to the 5th over 5. And we are going to evaluate that from 0 to 1. And when you evaluate that from 0 to 1, we are going to have, let's do the top one first. We're going to have 2 minus 1/3 minus 1/5 minus the lower limit. And your lower limit, when you evaluate at 0, that just gives you 0. So you do whatever it is that you want to do. I'm going to find the LCD, which is 15. So 15 times 2 is 30 minus 5 minus 3 over 15. And that gives us 30 minus 8, that's 22 over 15. And remember, this is the area, and since you're talking about area, the units will always be square. So if you have any questions, please let me know. Otherwise, if you like the video, also please let me know. Otherwise, I'll see you next time. Bye-bye.